All right, welcome to section 2.2 part 2. We're still talking about polynomial functions, and today we're actually going to learn how to graph polynomial functions. Okay, so we're going to actually learn what we learned in part 1 and apply it to the graphs. All right, so let's not forget about the leading term test. Okay, this tells us what our this basically tells us what our end behavior does depending on the leading term. Okay, so notice, remember, n is your exponent, a n is your coefficient. So if your an is positive, so just anything positive, and your n is odd, your exponent's odd, then the right's going to go up, left is going to go down. If your leading term is a negative and your exponent is still odd, then the left is going to go up and the right's going to go down. Okay? If your an is positive, but your n is even, so 4 instead of 3, then they're both going to go up. And if your leading term is a negative and your exponent is even, then both ends are going to go down. So that's the leading term test. All right, we will talk more about repeating zeros in a second when we do some examples, so we'll come back to this chart. But here are the steps to graphing polynomial functions. Step 1. Apply the leading term test, and I'll show you how to do that. Step 2 is to determine all the zeros and how many of them, this should be them, are repeating. We're going to find a few additional points in between all the zeros in each zone, and I'll show you how to do that. And then the last step is to graph the function. Okay? So this actually isn't as hard as it looks, but we'll work through this slowly to make sure everybody's on the same page. All right, so we're going to graph the following function. All right, so step 1 is to do the leading term. So the leading term is x times this x times x with this power of 2, so x squared. So x times x times x squared is 1x to the 4th. X times 2x's is x to the 4th. Okay, so we have a positive a value and a even exponent. Okay, so let's look at the even. Okay, so odd, so evens are down here. Okay, and it is positive, so we're both the left and the right are going to go up. Okay, so if you want to draw a little picture, both the right and the left are going to go up. That's all step 1 is going to tell us. So you take the leading terms, you multiply them all together, and you can kind of see what your leading exponent is going to be. All right. Step 2 is to find the zeros. Okay, so you take what you have here. So x, when it's x by itself, that equals 0. X plus 1 will be x equals -1, and x minus 2 will be x equals 2. You take the opposite signs, and then when x is by itself, you use 0 as your 0. Okay. The only thing different here is notice that this particular 0, there are 2 of them. So this is multiplicity 2. Okay, and we'll talk more about that when we draw the graph. We're going to have to do something with that multiplicity of 2. Okay, so that's step 2, determine your zeros. 0, -1, positive 2. Positive 2 is a double 0 because of the exponent of 2. All right, so that's step 1, or step 2. So what we're going to do now is we're going to plot these zeros on our grid. So 0, -1, 2. So 1, 2. All right, so there are our 3 zeros. Okay, now what we have to do for step 3 is to test all of our zones. We have zone 1, zone 2, zone 3, and zone 4. So we have to do left of our first 0, in between all the zeros, and then to the right of our last 0. So we have 4 zones for this one. So we have to just test those numbers in our original equation. All right, so give me a number to the left. So our first 0 is -1. So give me a number to the left of -1. Let's just try -2. So we're going to plug -2 into our function and see what we get. So everywhere I see an x, I'm going to plug in -2. So -2 times -2 plus 1 times -2 minus 2 squared. Okay, so let's do this math here. -2 times -1, -2 minus 2 is -4 squared is 16. So -2 times -1 is 2. 2 times 16 is 32. All right, so there's one number we're going to plot. So that's zone 1. That's our zone 1 number, f of -2. All right, so now we're going to do a zone 2. In between, we have to go in between these two zeros. So a number in between -1 and 0. So let's do negative 0.5. Negative 0.5. So we're going to plug in negative 0.5 where these negative 2's were. So negative 0.5, negative 0.5 plus 1, negative 0.5 minus 2 squared. So negative 0.5 times, so negative 0.5 plus 1 is 0.5. Negative 0.5, that's a negative 2.5 squared. All right, so we're going to use our calculator for this one because of the decimals. All right, so let's just multiply this out. Let's do our parentheses first. So negative 2.5. We're going to put that in parentheses, sorry. So negative 2.5 squared times, oops, only 1.5 times negative 0.5. And we're going to get an answer of negative 1.5, negative 1.56. So f of negative 0.5 is equal to negative 1.56. All right. So now we have to go between our next two zeros. So between 0 and 2, we're going to plug in 1. So let's do 1. All right. So I'm going to extend my page here. So f of 1. So everywhere there's a negative 0.5, I'm going to plug in 1. So 1 times 1 plus 1, 1 minus 2 squared. So this one should be easy. 1 times 2 times negative 1 squared. So 1 times 2 is 2. Negative 1 squared is 1. So 2 times 1 is 2. So f of 1 equals 2. So that's going to go on our grid. Okay, so we've tested zone 1, 2, and 3. Now we need to test zone 4. Give me a number to the right of 2. Let's just do something easy. Let's just do 3. That's to the right. So let's plug in 3. So I'll do 3 over here. So f of 3. So 3 times 3 plus 1 times 3 minus 2 squared. Make sure that equation's correct. Yep. All right, so 3 times 4. 3 minus 2 is 1, 1 squared. So 12 times 1 is equal to 12. So f of 3 is equal to 12. Okay, so now we're going to plot those points that we just figured out. All right, so let me get rid of these zones. We don't need this anymore. All right, and now we might have to change our units here. So we need to go up to 32. We have negative 1.56, 2, and 12. So I'm going to go by... let's see, let's go by 4s. So let's go by 4. So here's 4, 8, 12, 16, 20, 24, oops, go higher, 28, 32. Okay, so I'm going to go by 4s. All right, so let's plug in our points now. Our first point here is negative 2. I plugged in negative 2, I got 32. So negative 2, I got 32. That's up here. Then the next one was negative 0.5, negative 1.56. So negative 0.5, so that's like really close here. It's like down here. All right. And then I plugged in 1, I got 2. I plugged in 1, I got 2. So I plugged in 1, I got 2. So that's like right here. And then, last but not least, I plugged in 3, and I got 12. I got 3. So 1, 2, 3, 12, which is up here. All right, so remember, our graph needs to look like this. All right, so we come up here, and notice we go down here to this point. All right, now I'm going to come up to that point right here. So remember, this is a smooth curve. And then now, here is where we have to pay attention to this multiplicity of 2. If it's a multiplicity of 2, what does it say here? If a 0c has an odd multiplicity, so we're at an even multiplicity because it's 2. So the graph of f is tangent to the x at x equals c. It does not change signs. So what this means is it's tangent. So it just goes down, touches, and goes back right in the same direction. All right, so it doesn't actually cross, it just comes down, touches, and then goes right back up in the, okay? So single roots cross the x-axis, you cross, but then when it's a multiplicity of 2, it just goes down, touches, and goes right back up in the same direction. So notice my shape kind of looks like what I thought it did. Okay, so we find our zeros, we figure out numbers in between, and then we draw our graph. All right, so let's try one more. All right, so step one, let's do our leading test. So negative 2x times x times 3x cubed. Okay, so 3x cubed. So I have, this is negative 2x times x is negative 2x squared. 3x cubed, 3 times 3 times 3 is 27x cubed. So let's see what I have here. X squared times x cubed is x to the 5th. Negative 2 times 27 is negative 54. So negative 2x times x times 3x cubed. So negative 54x. So we have a negative and an odd. Negative and odd. So we have negative, odd, negative, odd. So the left is going to go up and the right is going to go down. So left is going to go up. So left, I'll draw it over here. Left is going to go up. Right is going to go down. So that's what our shape's going to look like. All right, so that's step one. Step two is to figure out our zeros. Our zero. So when x is by itself, it's just 0. So x equals 0. X minus 4 is x equals 4. 3x minus 1. So basically we have to do 3x minus 1 equals 0 and solve this. So plus 1, 3x equals 1. Divide by 3, x equals 1/3. So x equals 1/3 is our last root. And then now, what do we notice? This is a multiplicity of 3. Multiplicity equals 3. So we'll come back to that. All right, so let's plot our zeros. So we have 0. We have 4. 1, 2, 3, 4. And we have 1/3. So let me move this dot a little bit. I made it a little too big. All right, and then our last one is at 1/3, which is really, really close here. It's kind of hard to do on this grid. All right, so we have to test our zones. We have to the far left, we have in between 0 and 1/3, we have in between 1/3 and 4, and then we have to the right of 4. All right, so those are the numbers we're going to plug in. All right, so let's see here. So step 3, okay, we're going to plug in numbers into our equation. All right, so let's do a number to the left of 0. So let's do -1. All right, so we're going to plug in -1 into our original function, which is up here. So -2 times -1 times -1 minus 4 times 3 times -1 minus 1 cubed. Okay, so we're plugging in -1. Okay, I'm going to tell you right now, you can do all this math, but you're going to get 640. So f of -1 is equal to 640. All right, now let's test a number between 0 and 1/3. Okay, so the easiest one to do would be 0.25. 0.25. Okay, and when you plugged 0.25 in, you get -0.03. I'll save us some time. Okay, we're not going to plug that in. We're not going to, but you could plug in -0.5 or 0.25 into here, and you can get an answer of -0.03. All right, so now we need a number to the right of 1/3. So let's just do 1. When you plug in 1 and you do the work, you get 48. Okay, when you plug in 1 into the original function, you get 48. And then last but not least, we need a number to the right of 4. Okay, so let's just do 5. You don't need to get fancy. We're just going to plug in the very first number to the right of 4. And when you do that, you get -27,400. Okay, 27,400. All right. So notice we have big y-axis. We have 640, -27,000. I'm gonna make my y-axis go by 500s. So we'll go by 500, 1,000, 1,500. 2,000, so on. Okay, and we'll go down the same exact thing. We're just going to do 1s on the x-axis. Okay, so let's plug in our first number. So if we plug in -1, we get 640. Okay, so -1, 640. So it'd be probably about right here. All right, now when we come down, 0.25 is equal to -0.03. So that's really, really close here. It's really, really close. 1 is equal to 48. So 1 is equal to 48. That's about right here. So this is a very strange one. And then negative 27,400. So at 5, we're way down. We're way down here. I'm not going to put negative 27,000 on it, but we're way down here. All right. So let's draw our graph now. Okay. Now, at 1/3, we have a multiplicity of 3. So let's see what our chart says for multiplicity of 3. If you have odd multiplicity, f crosses the x-axis. So all these zeros are going to cross the x-axis. All right. So all of them. So here's our first point. We're coming down. We get to a 0. We're going to cross. We're going to go through that point. We're going to cross again. We're going to go to our 0, and then we're going to go way down. And we're going to put our arrows. So notice our left side goes up and our right side goes down. Okay, so this is pretty challenging. You may have done this in Algebra 2 last year. I'm not sure. I know we didn't do it last semester, but we're going to save this example for in class so we're on the same page. But this is pretty tough stuff, but I think you can handle it. So have a good night. I will see you tomorrow.